Hi guys, welcome to the Logistic Regression Project Solutions lecture now. I am sure that you have already completed the tasks without the help of the solution lecture. However, as a part of this course, let's move on and solve the required tasks one by one. So the first thing is we need to run this cell to import these required libraries, pandas, numpy, matplotlib, and so on. Let's run this cell. Read the data into a DataFrame df. You are using pd.read_csv and reading that data into df. Let's run this cell. Now we have our data into DataFrame df. Let's select the required features here because we are going to work with 10 real valued features in this project only. Let's run this cell and now we have the required features in df. The first task is asking for check the head of your data frame. So we have data frame df. We need to call head on our data frame df. Let's run this cell. And here we have radius mean, texture mean, area mean, and the last column, diagnosis column, MMM, and there are B's as well in this column. The next task is, can you tell how many entries you have in your data? And is there any missing value? So we need to call info on our data frame. So df.info. Let's run this cell and here we have the same output, 569 entries. So if you notice each column here, you will find there's no missing value in your data, like 569, 569, and so on. The next task is get a summary on basic statistics for your data. You have a function describe. Let's call that function on our data frame, df.describe, and run this cell. Here we have a basic statistics on our data frame, count, mean, and so on. So the next task is how many unique targets we have to predict. So you have to find out the unique targets. Let's grab the diagnosis column and call unique on that column. So df grab the column diagnosis and call unique. If we run this cell, here we have M and B. We have two types of cancers in diagnosis column, M and B. The next task is again very simple and hint is provided. I hope you still remember this value counts function. This is very useful. So once again, we need to grab this diagnosis column, df diagnosis. You can press tab for autocomplete and call value underscore counts. Run this cell and here we have type B 357 and type M 212. So the type B cancer is common. Moving forward, please recreate the plot below. This is a simple count plot and once again on the diagnosis column. Let's call count plot using cbourne on the diagnosis column. So SNS dot count plot. You can always press tab for autocomplete and then grab the column diagnosis. If we run this cell, here we have the same output. We have diagnosis along x-axis and counts, which are number of observations in our dataset for each target values along the y-axis. Let's make it slightly smaller just to fit on the screen. And here we have both plots on the same screen. So we got the same output here as well. Next question is recreate the plot below to overview your entire data frame. So this plot is a simple pair plot on our complete dataset. Let's use SNS pair plots function to recreate this plot. So SNS dot pair plot, pass in the data frame df. And another thing you notice here, you see you have two colors here, so we need to pass in hue as well. Let's pass in target columns, which is diagnosis column, as hue. So hue equal to diagnosis. Let's run this cell. This will take some time because this is relatively bigger data set. So here we have the same output. We are passing hue as a diagnosis. So we are separating the data points based on the unique values in our target column, which is diagnosis. So moving forward to the machine learning section, the first task is please import train test split method. Let's import this train test split here. So from Scikit-learn, and train test split is a part of model selection. Model selection import. You can press tab for autocomplete, simple way. So let's run this cell. No error, we have imported this train test split. Separate data into features and target data sets. So we have our data frame DF. So diagnosis is not the features. We have to pass diagnosis column to Y and all other columns to capital X. So our capital X, which is features, will be X equal to df dot. Let's use drop here. And which column we want to drop? We don't need diagnosis column in X. And we need to pass in axis as well because we are considering columns here. So axis is equal to 1. And the column we are dropping in capital X, we need in Y. So Y equal to df and grab the column diagnosis. And run this cell. We don't have error, so we have separated the data into features and target data sets. The next one is split the data into train test data sets. Use test size 0.3 and random state 42. If you use these numbers, you will get the same results, what we are going to get in this project. To avoid some coding, you can press Shift Tab, move down, and copy these two lines. Paste it here, delete these dots, and let's split this code into two lines. Here we have xtrain, xtest, and so on. We need to change this test size to 0.30 and random state is the default value. Let's run this cell, and now we have splitted the data into train and test dataset. Please import logistic regression and create its instance. Logistic regression is a part of linear model. So let's import logistic regression from Scikit-learn's linear model part. Import sklearn dot linear model, and we want to import, this should be from actually, import logistic regression. So here we have, and he's asking to create its instance as well. So let's copy this logistic regression and create an instance within the same line. Log R logistic regression and paste it here. Run this cell. So there's no error. We have successfully imported the logistic regression and created its instance. The next task is how to fit a logistic regression model on the trained dataset. Let's make it a little bigger here as well. So how to fit the logistic regression model on the training dataset? If you remember, we need to call fit on the instance log R and pass in the train data. So log R dot fit and pass in capital X train and Y train. Let's run this cell, and here we have the same output. So now we have the fitted model to our train dataset. We can do the predictions now. Don't worry about these parameters at this stage. So the next task is predict values for the testing data. So now you need to do the predictions using your fitted model. So predictions equal to log r dot. So instead of fit, now you need to call predict and pass in your test dataset, which is x underscore test. Let's run this cell. There's no error, so we have our predictions in predictions variable here. Now we have predictions and observed values. Our observed values are already in y underscore test. The next task is create a classification report for the model. Also import the required modules for this purpose. So we need to import the classification report first. Let's import classification report from Scikit-learn matrices. From Scikit-learn dot matrices import. Press tab and you will see this option here. And let's run this cell. No error, we have imported this classification report. I want to add cell here so that I don't lose this information. And then print classification report, pass in the test values and the predictions, and run this cell. And here we have precision recall F1 score support, and we got the same results from our dataset because we use the same random numbers and same split in our dataset. So the next and last question is, could you please display the confusion matrix? So you need to run this cell first because you want to import confusion matrix. I'm going to add another cell here again so that I don't lose this information. So insert cell above and now print confusion matrix, pass in y-test and predictions. And if we run this cell, here we have 1, 0, 3, 5, 6 and 57. We got the same results. We have some true positives and true negatives here as well. However, our model has done pretty good job based on the given features. So just a quick overview on the solution lecture. First thing is we imported libraries, then we read the dataset into DataFrame DF, selected features to work with. Then as usual, we displayed the head of our data frame, called info on our data frame, and then used describe to get the basic statistics on our data frame. Then we moved on and explored our dataset. How many unique values in the target column we have. Then we got a couple of plots and moved on to the machine learning section. You notice that machine learning part has quite few steps, and you follow those steps in a sequence. Like you import train test split, then you separate the features and target values, then you split your data, then you import logistic regression or the required model, create its instance, and then call fit. Once you have the fitted model to your trained data, you do the predictions. And after that, you evaluate your model. And in this case, we are printing classification report and confusion matrix. And I hope you still remember what is confusion matrix from the theory lecture. So this was all about your logistic regression project and the logistic regression section as well. It's always good to do practice. If you need, go through the lecture again and try to solve all these tasks yourself. You will clearly see improvements in your skills. See you in the next lecture, where we are going to learn another machine learning model with some real dataset examples. Good luck.